Okay guys, let's begin the discussion of the questions. First question says that if in the expansion of a minus 2b whole to the power n, the sum of 5th and 6th term is 0, then find the value of a by b. When I talk about the expansion a minus 2b whole to the power n, basically in this expansion, what is the general term? General term is given by NCR a to the power n minus r minus 2b to the power r. If I am saying 5th and 6th term add up to give you 0, so T5 can be written as T4 plus 1. So this becomes what? NC4 a to the power n minus 4 minus 2b whole to the power 4. And what about the 6th term? It is T5 plus 1, which is NC5 a to the power n minus 5 minus 2b whole to the power 5. Now they are adding up to give you 0. You know that minus 1 to the power 5 is actually minus 1 and minus 1 to the power 4 is 1. So when you add both of them you get 0. You actually are getting what? NC4 a to the power n minus 4 2b to the power 4 is equal to NC5 a to the power n minus 5 2b to the power 5. Right, I have just sent this T6th term to the right hand side and hence I have got this, which means NC4 upon NC5 is equal to a to the power n minus 5 upon a to the power n minus 4 into 2b to the power 5 upon 2b to the power 4. Right, so a to the power n minus 5 upon a to the power n minus 4, 2b to the power 5 upon 2b to the power 4. This gives you what? A to the power n minus 5 minus n plus 4, which is a to the power minus 1, and this gives you what? Into 2b. Because 2b to the power 4 gets cancelled, you're left with 2b, which eventually gives you what? Let's see. This is 2 times b by a. So what is a by b? If this is 2 times b by a, actually a by 2b will be equal to NC5 upon NC4. So a by b is twice of NC5 by NC4. What is NC5 by NC4? It actually gives you n factorial upon 5 factorial, which can be written as 5 into 4 factorial into n minus 5 factorial, and then you get n factorial because it is upon NC4. So n factorial, this is 4 factorial, n minus 4 into n minus 5 factorial. So this gets cancelled out, this gets cancelled out, this gets cancelled out. So you are left with what? This becomes 2 into n minus 4 by 5, and that is what is your a by b. So a by b turns out to be 2 into n minus 4 by 5, which is option number B. Now the moment we move to the next question, let's see what it says. It says in the expansion of 1 by x plus x tan x whole to the power 5, the ratio of 4th term to the 2nd term is 2 by 27 times pi to the power 4, then the value of x can be what all among these 4 options. So here when I am talking about 4th term to the 2nd term, again r plus 1th term will be what? 5cr 1 by x to the power 5 minus r and x tan x to the power r. So you have ratio of 4th term to the 2nd term. What is 4th term? 4th term is 5c3 1 upon x to the power 5 minus 3 x tan x to the power 3. So this gives you 5c3, this is x cube and this is x square, so you're left with x tan x to the power 3. right? This was x cube, this is x square, so just left with a single x over here and tan x whole cube. Similarly, this is the fourth term. What the second term is? 1 plus 1. So this is 5c1, 1 by x to the power 1, or 1 by x to the power 4 actually. So 1 by x to the power 5 minus 1, x tan x to the power 1. So from here you get 5c1 tan x whole upon x cube. What is 5c1? 5 factorial upon 1 factorial into 4 factorial. So this gives you 5 tan x whole upon x cube, and this gives you 5c3. 5c3 is nothing but 10. So this is 10x into tan cube x. Right? Why? Because this is 5 factorial upon 3 factorial into 2 factorial, which makes this 5 into 4 into 3 factorial, 20 upon 2, that is 10. So 5c3 is 10. Now it is saying ratio of fourth term to the second term. So what is this trying to say? It is saying ratio of fourth term to the second term. So 10x tan cube x whole upon 5 tan x, and here x cube is given by 2 by 27 pi to the power 4. Eventually what are you going to get? This gets cancelled. This is 2, so you get 2 x to the power 4 tan square x equals 2 by 27 pi to the power 4. 2 gets cancelled. You are left with x square tan x equals plus minus 1 by 3 root 3 pi square. And what is that x which is actually going to satisfy this? It is nothing but pi by 3 and minus pi by 3. So your answer is pi by 3 and minus pi by 3. Moving on to the next question, we have this expansion given to us. What is this equal to is the question. Now see, this is pretty simple to actually first of all decode how this can alternatively be written. I can write this as minus 1 to the power k minus 1 nck a minus k whole square, right? Because C1 is nothing but NC1, C2 is nothing but NC2, so I can write it as NCK a minus k whole square. This k is running from 1 to n. Now this can be resolved further to minus 1 to the power k minus 1 NCK a square minus 2ak plus k square. The moment you get this, your entire summation boils down to summation k going from 1 to n minus 1 to the power k minus 1 nck into a square minus 2a, again k going from 1 to n minus 1 to the power k minus 1 nck into k, this k, plus summation k running from 1 to n minus 1 to the power k minus 1 nck into k square. Now one by one let's try to understand. If I talk about this summation, I can write this alternatively as what? So this can alternatively be written as 1 minus summation k going from 0 to n minus 1 to the power k minus 1 nck, and this is nothing but equal to 0. So from here you get 1 as the answer of your this summation. Now when I am talking about this particular summation, this can alternatively be written as what? This can alternatively be written as summation k running from not 1 to n but 0 to n minus of minus 1 to the power k into nc k, right? And this is nothing but equal to 0. Here also this will be k and not k minus 1, this is k. Fine. After this, when I talk about this summation, this again can be written as summation minus 1 to the power k nck into k square with a minus sign outside because I am taking k from 0 to n. And this again is equal to 0. So you are basically getting a square into 1 minus 2a into 0 plus 0. So you basically get a square into 1, and therefore answer turns out to be a square. A square into 1 minus 0 actually gives you just A square as the answer. Now if you move on to the next question, what is it that we have now? Let's see. The value of n, what is it when all these things are basically taking place? We need to match the entries in column 1 to column 2. Coefficients of x to the power 7 and x to the power 8 are equal in the expansion of 3 plus x by 2 whole to the power n. Again, if I talk about the general term, it is equal to what? It is NCR 3 to the power n minus r, x by 2 to the power r. Right? I am talking about the 7th and the 8th terms. This is T6 plus 1 and then I want T7 plus 1. T6 plus 1 gives you what? This is NC6 3 to the power n minus 6, x by 2 to the power 6. Right? And this becomes NC7 3 to the power n minus 7, x by 2 to the power 7. Right? 3 to the power n minus r, x by 2 to the power r. Now, if I am saying that coefficients are equal, if the coefficients of x to the power 6 and x to the power 7 are equal, that means x to the power 6 has coefficient what? NC6 3 to the power n minus 6 upon 2 to the power 6, and coefficient of x to the power 7, and this is x to the power 8. If I talk about coefficient of x to the power 7, it is this actually, and coefficient of x to the power 8 will be NC8 3 to the power 8, x to the power 8 upon 2 to the power 8. So this is coefficient of x to the power 7. This is coefficient of x to the power 7. This is equal to coefficient of x to the power 8. And now from here, when you try to talk about what is the value of n, you basically get, this is 7, you basically get NC8 upon NC7. NC8 upon NC7 gives you 3 to the power n minus 7 into 2 to the power 8 upon 2 to the power 7 into 3 to the power n minus 8. So this gives you what? This is 3 to the power n minus 7 minus n plus 8. So this is 3 into 2, right? And this is NC8 upon NC7. From here, you are going to get n equals 55. So the first very A gets matched to R. So corresponding to A, you get R shaded exactly in a similar manner. Coefficients of x square and x cube are equal in the expansion of 3 plus 9x by 7 whole to the power n, exactly in the same fashion. When you follow, what is it that you get? You basically get B getting matched to S. It is for n equals 9 that coefficients of x square and x cube are equal in the expansion of 3 plus 9x by 7 whole to the power n. Then you have NC6 equals n minus 1 C5 plus 1. Now over here, it's pretty simple to understand. This can be written as n minus 1 C5 plus n minus 1 C6 equals n minus 1 C5 plus 1, which implies n minus 1 equals 6 and therefore n equals 7. So C gets matched to Q. And NC2 equals 990 is very, very simple. Just plug in n equals 45. 45 C2 is 990 and therefore D gets matched to P. Clear? Moving on to the next, we have, this is my N and CR is actually NCR. Statement 1 and statement 2 are given to us. Let's talk about them. Over here, C C0 minus C1x plus C2x square minus C3x cube plus and so on. This can be written as 1 minus x whole to the power n. We have done this expansion. Now what you do is you multiply both sides by x to the power k minus 1, okay? And then what you do, you integrate from 0 to 1 both sides. When you do that, you basically get your statement 2. What do you get? You get your statement 2, which is C0 by k minus C1 by k plus 1 plus C2 by k plus 2 minus and so on minus 1 to the power n Cn by k plus n. Okay, and on the right hand side also you are going to get integral from 0 to 1, because this is 1 minus x to the power n, you multiplied what, x to the power k minus 1 both sides and then integrated from 0 to 1. So you are very easily going to get x to the power k minus 1 into 1 minus x whole to the power n dx. Now when you put k equals 2, for k equals 2 you get c0 by 2 minus c1 by 3 plus c2 by 4 and so on minus 1 to the power n Cn by 2 plus n. Right? Here when you put k equals 2, you basically get x into 1 minus x to the power n dx. Similarly, when you put k equals 3, you basically get c0 by 3 minus c1 by 4 plus c2 by 5 and so on minus 1 to the power n Cn upon 3 plus n. So when you put k equals 3 in here, you get 0 to 1 x square 1 minus x to the power n dx. Fine. Now what you do is, this is 1, this is 2. When you perform the operation of 1 minus 2, you basically get this minus this, this minus this, this minus this, this minus this. When you do, you get your statement 1. So statement 2 over here is actually implying statement 1 when you are performing the operation, when putting k equals 2, k equals 3 and then subtracting them, you get c0 by 2 into 3. Then you get c1 by 3 into 4 and so on minus 1 to the power n Cn by n plus 2 into n plus 3. And what is it that comes on the right hand side? Let's try to understand, because then only we will be able to verify that statement. It will be integral 0 to 1 x minus x square times 1 minus x whole to the power n dx. The moment you have got this, it's time to simplify this expression. You've got this, so you basically have x 1 minus x, so this becomes x 1 minus x whole to the power n plus 1. Now see this, you know that 0 to a fx dx is f of a minus x dx from 0 to a. So this becomes integral from 0 to 1 minus x into x to the power n plus 1 dx. Right? So this becomes x to the power n plus 1 dx from 0 to 1 minus x to the power n plus 1, so it is n plus 2 integral from 0 to 1. So this is x to the power n plus 1 minus x to the power n plus 2. So this is x to the power n plus 2 by n plus 2 from 0 to 1, which is 1 upon n plus 2. Similarly, this is 1 upon n plus 3. So n plus 3 minus n minus 2 gives you 1 upon n plus 2 into n plus 3. And that is what you have basically in here, 1 upon n plus 2 into n plus 3. Clear? So yes, it is true that this statement is equal to this, and this is implying this particular statement also. So statement 2 is true and statement 1 is also true. So you have both these statements are true. In fact, the options can be that statement 2 is implying statement 1. So yes, statement 2 is actually implying statement 1. Let's talk about the next question. It is a paragraph question. Let's talk about this. It says that 1 plus x square whole to the power n is this expression. Which of the following is true? Now over here, just observe the options very, very nicely. If you replace x by 1 by x, you get what? 1 plus 1 by x plus 1 by x square whole to the power n equals summation ar 1 by x whole to the power r running from 0 to n. Now the moment you get this, you know this can be written as x square plus x plus 1 whole to the power n upon x to the power 2n equals this. What you do is, You can see it's n minus r, 2n minus r stuff written over here. So basically when you say summation r going from 0 to 2n, a to the power 2n minus r, 1 by x to the power 2n minus r, then what you get? What you get when you perform this operation of a 2n minus r, x to the power 2n minus r, or let me make this. This is actually x to the power minus r. 1 upon x to the power r, x to the power minus r. This is x to the power 2n minus r. Right? This exactly will be equal to 1 plus x square whole to the power n, which is nothing but summation ar x to the power r. Understood? So from here you are very easily getting that a 2n minus r is equal to ar. The moment first option has been marked that a 2n minus r is equal to ar, what happens to the next? Let's see. So here we have a 2n minus r is equal to a r. Then you have what is the value of this. Now this is very simple. If in the place of x you put 1, you get 1 plus 1 square whole to the power n, which is 3 to the power n, and here you get summation r going from 0 to 2n ar. So basically what you get is, let's write it down. What you get is, you get summation ar, r going from 0 to 2n equals 3 to the power n. When you expand this, you get a0 plus a1 plus a2 and so on, a2n. But you know ar equals a2n minus r, so basically this becomes twice of a0 plus a1 plus and so on an minus 1, with an left alone, is also equal to 3 to the power n. So because of the first option, I am getting the second option correct in here. Next we have, if a0 square minus a1 square plus a2 square minus a3 square and so on is k an, then k is equal to what? Okay. If we are talking about this particular expression, now you can see that I can say that, okay, so first of all in the expansion that we just did, if I replace x by minus 1 by x, I get 1 minus 1 by x plus 1 by x square whole to the power n equals summation ar, r going from 0 to 2n, minus 1 to the power r, and this minus 1 upon x to the power r. Now if you realize that a0 square minus a1 square plus and so on, a 2n to the power 2n basically is equal to what? This can be written as coefficient of the constant term, in where? In 1 plus x square whole to the power n into 1 minus 1 by x plus 1 by x square whole to the power n. That means what is this equal? What is this expression equal to? This is 1 plus x square whole to the power n, and this is what? X square minus x plus 1 whole to the power n whole upon x to the power 2n. Or I can say it is the coefficient of x to the power 2n in this expression, which is a plus b, a minus b. So 1 plus x square plus x, 1 plus x square minus x, which is 1 plus x square whole square minus x square whole to the power n. Right? Which is coefficient of x to the power 2n in 1 plus x square whole square minus x square whole to the power n. So what do you basically get? This is 1 plus x square whole square minus x square whole to the power n, which means a square plus b square plus 2x square minus x square. Right? This becomes 1 plus x to the power 4 plus x square whole to the power n. If I take x square as y, I will be interested in y to the power n. So it is equal to coefficient of y to the power n in 1 plus y square whole to the power n. Isn't it? Which is equal to an. So if I am saying that this is equal to an, that means k is actually equal to 1, because this particular thing was coefficient of x to the power 2n in this expansion, or coefficient of y to the power n in this expansion, which is an, and therefore k turns out to be equal to 1. Clear? Let's look at the next question. The coefficient of x to the power 2021 in the expansion, this is what? Let's see. So here if I talk about this, I can write this as 1 minus x into 1 minus x to the power 2018 into 1 plus x square to the power 2018. So this is 1 minus x into 1 plus x square whole to the power 2018, which is 1 minus x, and this is 1 minus x cubed to the power 2018, which is 1 minus x cubed to the power 2018 minus x into 1 minus x cubed to the power 2018. Now see, every term in this particular expansion will be of the form x to the power 3k, and every term in this expansion will be of the form x to the power 3k plus 1. But actually this is of the form x to the power 3k plus 2, right? And therefore its coefficient is 0. Clear? Because here we have 3k, here 3k plus 1, and this is actually 3k plus 2, which is not of the form of 3k or 3k plus 1, so its coefficient will be 0. The integer associated to this question is 0. After this, what you have? Let's see. For n greater than 2, let CR be NCR, Fn is this expression, then 2 to the power minus 5 f of 6 is equal to what? Now you know that C0 minus C2x square plus C4x to the power 4 and so on can be written as, okay, so if I take plus only, everything is plus, this is 1 by 2, 1 plus x whole to the power n plus 1 minus x whole to the power n. Right, multiply x throughout, you get C0x plus C2x cube plus C4x to the power 5 plus and so on 1 by 2 x into 1 plus x to the power n plus x into 1 minus x whole to the power n. Now you differentiate. When you differentiate, you get C0 plus 3c2x square plus 5c4x to the power 4 plus and so on 1 by 2. This becomes first number into differentiation of second number plus second number differentiation of the first number. So you have plus 1 plus x to the power n into d by dx of x, which is 1. Then you have plus again first number 1 minus x to the power, or n into 1 minus x to the power n minus 1 and minus 1 also. Right, this is x into differentiation of this, which is n into 1 minus x to the power n minus 1 into minus 1, and this is 1 minus x to the power n into d by dx of x, which is 1. Now what you do, if you put x equals 1, you basically get this expression, isn't it? If you put x equals 1, you get this expression. Fine, the moment you get this expression for x equals 1, what is it that you get in here? You get 1 by 2. For x equals 1, you get n into 2 to the power n minus 1 plus this is 2 to the power n, this is 0, this is 0. So that's what you get. The moment you get this, this becomes f of n equals, this is n minus 1 minus 1, this will be n into 2 to the power n minus 2 plus 2 to the power n minus 1. So f of 6 is what we need to find. It will be 6 into 2 to the power 4 plus 2 to the power 5. So 2 to the power 4 comes out, you are left with 6 plus 2, which is 2 to the power 4 into 8, that is 2 to the power 4 into 2 into 4. So this is 2 to the power 5 into 4. You want 2 to the power minus 5 into f6. So 2 to the power minus 5 f of 6 is 4. So 2 to the power minus 5 into f of 6, because I am bringing 2 to the power 5 to the left hand side. So 2 to the power minus 5 f of 6 is equal to 4. Practice these questions very nicely. That's it from my side. Thank you.